Good morning, guys. Now, today I'm going to discuss about the correlation coefficient in statistics part 1. Now, in these lectures, we have covered the correlation, types of correlations, scatter and dot diagram, correlation coefficient, and methods of calculations of correlation coefficients. Now, in part 2, we have discussed the four different type of example how to find the correlation coefficient. So now we start for the correlation. At the correlations before that, now in these lectures we are going to introduce the method of describing the relationship between the two variables and assessing the strength of their relationship. So far we have discussed the statistical technique concerned with the analysis of univariate data. It is based on the data on the single variables. Now in this lecture we consider the simultaneous variation of the two variables. That means that the bivariate data. Bivariate data means that suppose we are going to discuss about the monthly incomes and expenditure of a family, expenditure of for a number of families means that the monthly income is X and expenditure for a number of families is Y. Similarly, we're going to discuss about the amount of rainfall and the yield of a certain crop and the age of husbands and wives. These are types of example. Here is the two random variables are coming X and Y. Then we use for the correlations. So need to discuss about the correlation here. Correlations. Correlations means what? When changes in one variable, when change in one variable, when change in one variable are associated, are associated, are associated or followed by changes in the other variable is called correlation. Now it measure it measures the direction. It measures the direction and the strength of linear relationship linear relationships. For example, for example, the price of commodity increases increases with the reduction with the reduction with the reduction in its supply. And now the next is the yield of a crop varies with the amount of the rainfalls. So now we are going to discuss about the type of correlation. Types of correlations. The first one is positive correlation. Positive correlation. So suppose we take the x and y two random variable, x and y two random variables. Now one variable is increases corresponding to the other variables is also increases. That is known as the positive correlations. And now the next one variable is decreases and other variables is also decreases, that is known as the positive correlations. So now we move for the negative correlation here. Now the negative correlation, negative correlations means that here is the negative correlations when if increases in one variables, then corresponding to decreases in the other variables. If decreases one variables and corresponding to the other variables is increases, this means is give the negative correlations. That is known as the negative correlations. And now the third one is the linear correlation. Linear correlation. Now the linear correlations means what? When the plotted points lies is approximately on a straight line. Suppose we draw the graph where x-axis and y-axis, and we dotted points is given. Here is a straight line and dotted point is lies on a straight line. This the relation is known as the linear correlation. That is known as the linear correlations. And now for move for the next is perfect correlation. Perfect correlation. Now the if the deviation of one variable x is proportional to the deviation in other variable, then correlation is said to be perfect. In this case, plotted points on a graph lies exactly on a straight lines. And now it is divided in two parts. First is positive perfect correlation, correlation, positive perfect correlations. So now in this case, if increases in one variable is increasing, suppose we take the two variable x and y here, x and y. Now one increases in one variable proportional to increases in the other variables y, then the graph will exactly on a straight line. So we can draw here. This is the straight line and all the points in the positive correlation, one variable is increases proportional to increases in the other variable, that is known as the positive correlations. The origin. And now the second is negative perfect correlation, negative perfect correlation. There is x-axis, y-axis. Now one increases in one variable is proportional to decreases in other variable. The graph is exactly as a straight line. That is known as the exactly as a straight line. Exactly on a straight line. That is known as the negative perfect correlations. Negative perfect correlations. So now we move for the scatter, scatter or dot diagram. Scatter or dot diagram. Scatter or dot diagram. When we plotted the corresponding values of the two variables, taking one variables on x-axis and other variables on y-axis, and it shows the collection of dots. This collection of dot is called a diagrammatic, is called a dot diagram or a scatter diagram. Now it displays the nature of it displays the nature of relationship between relationship between two variable between two variables between two variables. So now in this case we have seen that this is represent the correlation positive correlation. Now here we draw x-axis, y-axis. Here in these cases, this is represented by what? This is represent the negative correlation, and previous we have seen that the positive and negative correlations, and now here is the next is what? And suppose we take the one rectangle, there is a no relations between this. There is no relation, is a no correlation, x-axis, y-axis, and origin, no correlations. Now the next we move for the correlation coefficient. Correlation coefficient, correlation coefficient, and it is also known as the Karl Pearson, Karl Pearson product moment correlation coefficient, correlation coefficient. Now this is the numerical measure of the correlation is called the correlation coefficient, and it is denoted and defined by rho xy is equal to covariance 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 of xy between xy under root variance the variance. Here we write the variance, here we write the variance of x into variance of y. Now another way we can write here summation of xy divided by n sigma x into sigma y, where where capital X is equal to deviation from deviation from the mean. Small x is equal to x minus x bar. Capital Y is the deviation from the mean. Small y bar is equal to y minus y bar. And now sigma x is equal to a standard deviation standard deviation of x rays, and sigma y is equal to a standard deviation of y rays. Now here n is what? Here n is the number of values of two variables, values of the two variables, And now after that we go for the covariance term. Here is the covariance. Suppose x and y two random variable is two series is given and x random variables contains the value of x1, x2 dot xn. Here the capital Y is also contained y1, y2 dot yn. This is the pairwise distribution ordered given the pair of this x1, y1, x2, y2, xn, yn in a ordered pair is given in the numbers. Then the covariance between x and y is a denoted and defined by it is denoted and defined by covariance of xy is equal to 1 by n summation of xi minus x bar into yi minus y bar I lies into 1 to n. And now the covariance term we can write in the form of expectation. Here we write the expectation of x minus x bar, y minus y bar. And now in a simplified form, and after simplify when we calculating and multiply here, we get the values of covariance term. Covariance of xy is equal to expectation of xy minus expectation of x into expectation of y. Now some notes is there. This is the covariance correlation coefficients and some notes. The first note is correlation coefficient always lies between -1 to 1. Now the second is the directions are same. That's why we can write direction and strength are same. That's why we can write xy rho of xy is equal to rho of yx. No problems. We can write it. And now the third is two variables. Suppose two random variables. Two random variables are said to be uncorrelated, uncorrelated, uncorrelated if expectation of xy is equal to expectation of xy into expectation of x into expectation of y. Uncorrelated means the linearity relate not linearly related. In this case, in this case, we can write covariance of xy is equal to 0 or correlation coefficient between x and y is also 0. Now the fourth is the two random variables are said to be orthogonal orthogonal if expectation of xy is equal to expectation of product of xy is equal to 0. Now the next is if either x or y has zero mean, then we write x and y. We write x and y are uncorrelated, uncorrelated, uncorrelated means x and y are orthogonal, orthogonal. Now sixth one is what? Two independent two independent variables. Two independent variables are uncorrelated, 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 but the converse, but the converse of, but the converse of the theorem, but the converse of this theorem, just we write here, converse of this theorem is not true. Not true means that the independent variables we can say that the uncorrelated and independent variables are uncorrelated means that then uncorrelated are variables are not a independents. So these are the properties of the correlation coefficients. So now we move for the calculation parts. So we go for the methods of calculation here. Here we go for the methods of calculation. Methods of calculation. Method of calculation. Now first one is the direct methods. We have discussed here the direct method. Direct method. Now in this case we write the formula here, just substituting the value of substituting the values of sigma x and sigma y in the above formula. In the above formula we get here rho xy is equal to summation of xy, and we write here under root summation of x square into summation of y square, that is known as the Karl-Pearson coefficient of correlations. Now write in this another form, we can write in another form, we can write this is the equation, we can take the equation number A, and now the another form of the formula of the formula A, which is quite handy for the calculations. That's why we can write here rho xy is equal to n summation xy minus summation x into summation y by under root, we can write here n summation x square minus summation x whole square, and here we write n summation y square minus summation y whole square. This is the formula we can write in a simple way. We write, and now the next is, we write for the next is a step deviation method, step deviation method, step deviation method. This is known as the general formula. Here for the general formula. Now direct method becomes very lengthy and tedious if the means of the two series are not integer. In such case, use a made of assumed mean. Here is use the assumed mean. Here use the assumed means A and B, and previously that the deviation were taken from the actual mean x bar and y bars. And now here we have concentrated the assumed mean. That's why we can write here, we can write x dash is equal to x minus a by h, y dash is equal to y minus b by k. Now we write the formula here, row correlation between x and y. We write the formula directly in a simplified form. Just we write for the formula in into summation of x dash y dash minus summation of x dash summation of y dash divided by under root of in summation of x dash square minus summation of x dash whole square into n summation of y dash square minus summation of y dash whole square. Here is observation is that the change of origin and units do not alter the values of correlation correlation coefficient correlation coefficient since since rho xy is a pure number, y is a pure numbers, rho y x as a pure numbers. So now we move for the coefficient of correlation for the group data. Correlation coefficient, correlation, correlation coefficient of group data, correlation coefficient of group data. So just we write the formula here, rho, it is denoted and defined by, here we write the formula, rho xy is equal to in summation of f x dash y dash minus summation of f x dash summation of f y dash divided by, here we write in summation of f x dash square minus summation of f x dash whole square. Now the variance of y also we can write in summation of f y dash square minus we can write here summation of f y dash whole square, where 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 x dash is what? X dash is deviation from assumed mean of x is equal to x minus a. A is the assumed mean, and y dash is equal to any constant we have derived. Deviation from assumed mean of y is equal to y minus b. And now the capital N is the total number of items. So these are the formula method of calculation of correlation coefficient. Suppose group data, so we can apply here, frequencies is given, without frequency we can use here. And now in this formula also we can take the h is equal to 1 and k is equal to 1. It depends the deviations and how to deviate for this, and after that we use this formula. So this is the formula and this is the first part of the correlation coefficients. So now we next parts we have discussed the four different type of problems. So must watch for the correlation coefficient of part 2. So thank you. Thanks for watching my video. So please like, comments and subscribe my channels.